Hi students, welcome back to iliyas maths. So previous class lo manamu AP intermediate mathematics textbook 2B lo integration chapter exercise 6C లో థర్డ్ రోమన్ లో 9 ప్రాబ్లమ్స్ కంప్లీట్ చేసాం కదా. ఇప్పుడు నెక్స్ట్ 10th ప్రాబ్లం. ఎస్, evaluate integration tan inverse of 3x minus x cube by 1 minus 3x square dx. సో ఈ ప్రాబ్లమ్ని డైరెక్ట్ చేసి చాలా లెంతీ ప్రాబ్లం అవుతుంది. సో బెటర్ in this problem you have to take a substitution method. That means put x equal to tan theta. Put x equal to tan theta. Then it stands for 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. So actually in this problem here 3 tan theta minus tan cube theta by 1 minus 3 tan square theta stands for tan 3 theta formula. Okay, yes. So first of all let us consider I equal to integration tan inverse of 3x minus x cube by 1 minus 3x square dx. Put x equal to tan theta and differentiate with respect to theta on both sides. Then we get dx equal to derivative of tan theta secant square theta into d theta. Here dx by d theta we transfer here d theta, so denominator will become as a multiplicand numerator. Yes. Next, now integration. Now substitute x equal to tan theta in this integral. Tan inverse of 3x minus x cube by 1 minus 3x square dx. This implies this equal to integration tan inverse of 3x here tan theta 3 tan theta minus tan cube theta by 1 minus 3 tan square theta into dx. Here dx is secant square theta into d theta, secant square theta into d theta, secant square theta into d theta. Okay, yes. So actually the formula for tan 3 theta, since tan 3 theta equal to 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. Okay, so substitute 3 tan theta minus tan cube theta by 1 minus 3 tan square theta is as tan 3 theta. Okay, yes. Integration tan inverse of tan 3 theta into secant square theta d theta. This stands for tan 3 theta. Tan inverse of tan 3 theta into secant square theta d theta. Yes. Now tan inverse and tan both are cancelled. So integration and the remaining term will be 3 theta into secant square theta d theta. Here 3 is constant, so we put it out. So constant term, this implies 3 integration theta into secant square theta d theta. So now by using highlighter rule, so here two functions are there in integral. So here first of all, in which function we may take as a first function, that means u, and which function we may take as a second function as a v. So by using ilate rule, ilate rule. So here inverse trigonometric function is here? No. Here no inverse trigonometric function. And also logarithmic function? No. So next algebraic function. Yes. We observe here algebraic function is here. So what is that algebraic function? So theta is the algebraic function. So consider first function u as a theta, and then remaining function is second function, obviously second function. Okay, yes. Now we may write integration by part formula. Integration uv dx equal to u integration v dx minus integration du by dx integration v dx whole dx. Okay, yes. Now substitute uv values, uv functions in this formula. So u, here u is theta, theta integration, v is secant square theta minus integration d by d theta of theta. Next integration secant square theta into d theta whole d theta. Okay, understand? Yes. Next theta, integration secant square theta formula. What is the integration secant square theta formula? So integration secant square theta is nothing but tan theta minus integration derivative of theta 1. Integration of secant square theta is tan theta. Tan theta. Here we may miss here 3 of theta tan theta minus integration tan theta d theta. This equal to 3 theta into tan theta minus integration tan theta d theta is nothing but log mod secant theta. Log mod secant theta plus integral constant c. So let us write this formulas. Integration secant square theta is nothing but tan theta plus integral constant c. Integration tan theta is nothing but log mod secant theta plus c. Log mod secant theta plus c. So now, so in this problem here we are taking put x equal to tan theta. So tan theta means here tan theta is equal to x. We may consider as tan theta is x. In this tan theta equal to x, we may transpose tan in right side. So it will become tan inverse x. Theta equal to tan inverse x. Okay, yes. Now this equal to 3 of theta is nothing but tan inverse x. So tan inverse x, tan theta is nothing but x. So that means x tan inverse x minus log mod secant of theta is nothing but tan inverse x. So tan inverse x secant of tan inverse x plus integral constant c. So problem will be completed. Okay, yes. Or we may substitute in terms of variable here also. Secant square theta, you know that secant square theta equal to 1 plus tan square theta. Secant theta equal to square root of 1 plus tan square theta. Secant theta equal to square root of 1 plus tan theta means x, 1 plus x square. Okay, so r here r this equal to 3 of x tan inverse x minus log mod secant theta means square root of 1 plus x square plus integral constant c. Okay, next 11th problem. Evaluate integration sin h inverse x dx. So in this problem, first of all, let us consider I equal to integration sin h inverse x into, so here only one function is here. We may take as two functions. That means sin h inverse x into 1 dx. So here, in which function is u and in which function is v? How can we find? By using Eilert rule. Okay, yes, by using Eilert rule. Let us write Eilert rule. Eilert rule. So inverse trigonometric function. Inverse trigonometric function means like trigonometric functions and also hyperbolic trigonometric functions also in this inverse trigonometric function. So here inverse trigonometric function is given here. So what is that? Sin h inverse x. So that's why we can take here first function is sin h inverse x and another function is remaining function is a second function, that means v. So let us write integration uv dx formula, which is nothing but integration by part formula. Integration uv dx equal to u integration v dx minus integration du by dx integration v dx whole dx. Okay. Now let us substitute uv values in this formula. So this will become u means sin h inverse x integration v here 1 dx minus integration derivative, that means du by dx of sin h inverse x integration v dx, that means dx whole dx. So integration sin h inverse x integration dx is nothing but x sin h inverse x minus integration derivative of sin h inverse x. So what is the derivative of sin h inverse x? So the derivative of sin h inverse x is 1 by square root of 1 plus x square, and integration dx is nothing but x. Let us x, so dx. So now let us here observe here. Right, next we can write a next step x sin h inverse x minus integration x by square root of 1 minus x square dx. Here 1 plus x square dx. Here, so if you observe this denominator function, so 1 plus x square, so the derivative of x square is 2x. In this numerator only x is here. So here we can write for 2x and also 1 by 2. Divide and multiply by 2. Then it will be easily, so the derivative function, denominator derivative function will be in numerator. So now it is in the form of, let us check it is in which of the form. So it is in the form of integration f dash of x by root f of x dx. So integration f dash of x by root f of x dx is nothing but 2 root f of x plus integral constant c. Okay, so carefully students, first of all you have to learn all formulas in integral calculus. So okay, yes, x sin h inverse x minus 1 by 2. So it is in the form of this formula. So here we can write 2 into root f of x dx. Here f of x is 1 plus x square. So that's why 2 into root f of x is 1 plus x square plus integral constant c. So here denominator, in this term denominator is 2 and also numerator is 2. Both are get cancelled. So the result will be x sin h inverse x minus square root of 1 plus x square plus integral constant c. So hence this problem will be solved. Okay. So next we will go to another problem. So 13th problem. Problem number 13. Evaluate integration. Problem number 12. Actually this problem you have to solve in your notebook. It's a homework problem. Cos h inverse x dx. And also I explain this problem. I will explain. Let us check once. If you solve this problem in your notebook, those students solve these problems, then you have to check the result. Is it correct way or not? If you are doing very well or not, let us check it once. Okay. Let us consider I equal to integration cos h inverse x. So here only one function is here. So the other function will be, yes, obviously that other function is 1 into 1 dx. So in which function is the first function and which function is the second function? How can we find out u and v? So by using, yes, obviously isolate rule. Yes, isolate rule. In this isolate rule, first function is inverse trigonometric function. So here inverse trigonometric function is cos h inverse x. So that's why we may take as it is a first function, and another function is obviously second function. Next we will write integration by parts formula. So integration uv dx equal to, yes, what is that formula? Recall it once. S u integration v dx minus integration du by dx integration v dx whole dx. Okay. S. So let us substitute these functions, two functions which are u and v. Okay. Let us substitute u. U is nothing but cos h inverse x integration v is nothing but 1, so dx 1 dx minus integration derivative d by dx of derivative of cos h inverse x. So cos h inverse x integration v dx means dx 1 dx whole dx. Yes. So integration dx is nothing but x cos h inverse x, x cos h inverse x minus integration derivative of cos h inverse x. What is the derivative of cos h inverse x? S. So the derivative of cos h inverse x is 1 by square root of x square minus 1, and integration dx is, yes, very good, x whole dx. Okay. Yes. So x cos h inverse x minus integration x by square root of x square minus 1 dx. Okay. X into 1 x. So here we observe here So the derivative of x square is 2x, but here only x is here. So that's why we can put it as 1 by 2 into 2. So now let us observe this integral function. So it is in the form of integration f dash of x by root f of x dx is what is the formula? 2 root f of x plus cs. Right, very good. Now this equal to x cos h inverse x minus 1 by 2 into 2 root f of x. F of x is here. What is here? F of x? X square minus 1 plus integral constant c. So this denominator 2 and numerator 2 both are cancelled. So this equal to x cos h inverse x minus root x square minus 1 plus integral constant. The result will be come. So the problem is completed. Okay, write it in your notebook and also check this answer and your answer both are same or not. Okay, next. So last problem in this exercise, let us solve it. Thirteenth problem, evaluate integration tan h inverse x dx. Okay, yes, let us consider I equal to integration tan h inverse x into, so here only one function is here, so another function will be obviously 1 dx. So in which function is u and in which function is v? So how can we find out? By using as obviously Eilate rule, Eilate rule. So here inverse trigonometric function is here. So that is the first function and another one is obviously second function. And we have to write it integral by part formula. So what is that formula? Integration uv dx equal to u integration v dx minus integration du by dx integration v dx whole dx. Very good. Now let us substitute u v functions in this integration by parts formula. So u tan h inverse x integration v, that means dx, minus integration d by dx, derivative of tan h inverse x integration v dx, so dx whole dx. So this equal to integration dx is nothing but x, so here tan h inverse x minus integration derivative of tan h inverse x. So what is that? The derivative of tan h inverse x is nothing but 1 by 1 minus x square. Integration dx is nothing but x, so dx. Okay, yes. Now x tan inverse x, so here x into 1 x. So let us observe in this integral function, so 1 minus x square is here. So the derivative of minus x square is minus 2x. So the derivative of minus x square is minus 2x. So that's why here we take a plus 1 by 2 integration minus 2x by 1 minus x square dx. Here plus into minus, obviously minus. So this two cancel, then obviously, so x the term will be remain same. Okay, so now let us observe this integral function f dash of x by f of x. Here not root is here, so that's why integration f dash of x by f of x dx is nothing but log mod f of x plus integral constant c. So let us write this formula. Integration f dash of x by f of x dx equal to log mod f of x plus integral constant c. Okay, yes, x tan h inverse x tan h inverse x tan h inverse, sorry, here also tan h inverse x tan h inverse x plus 1 by 2 log mod 1 minus x square plus integral constant c. So this is the required result. Okay, students, yes, understood? Yes, write it in your notebook carefully. Okay, students, this is the last problem in this exercise. So next continuation in next part. Okay, students, thank you, students, thank you for watching. Have a nice day. Please like, share, and also subscribe to your friends. Okay, thank you, students.